So, because we know how to solve or find the LU-factorization of a matrix, how does that apply to solving, let's say, a linear system using LU-factorization? So say we have the following linear system. How are we going to look for the LU-factorization? Well, for starters, as we've always done, we always convert we always convert linear systems to augmented matrices. So let's start with that. Okay. And you may have noticed that this is very similar to the last video. It's the exact same matrix. So we already have the LU factorization since it's the same matrix. And it's gonna look like this. You can skip ahead since so far it's a homage to the prior example. But if you didn't watch the video, don't worry, I got the LU factorization right here. Okay, and you may remember that for substitution, we have the equation y is equal to the upper triangular matrix times x, and we have to solve the system for the lower triangular matrix times y, which is equal to b, right here. And b, it's our -5, -1, -20, and we already have the lower triangular matrix, so let's stick with that. Because of that, we can solve for y. So we have 1, 0, 2, 0, 1, -4, 0, 0, 1 times our subscripts of y, which is equal to -1, -5, -1, -20. From there, we can already deduce a few things based on observation. We know that y1 is equal to -5, and we are also aware that y2 is equal to -1 based on observation. Now, here's the problem though. How are we going to solve for y3? Well, we already know y1 and y2. It's all a matter of direct substitution. So we have 2 times y1 minus 4 times y2 plus y3 is equal to -20. We know that it's 2 times -5 minus 4 times -1 plus y3, which is equal to -20, -10, and +4. That creates -6. And if we add 6 on both sides, we get y3 is equal to -14. Okay. Now, we have our y variables. And what about our x variables? Well, from our forward substitution equations, we now have y. We've always had the upper triangular matrix. Now we just have to solve for x. So let's do that. Okay. So our upper triangular matrix was already given. And we have subscripts of x, which is equal to our now discovered y variables. And from here, to solve for our y variables, is it a matter of observation? Not for all of them, no. Because for x3 is equal to -1, and that is from observation. And because we know the identity of x sub 3, we should be able to deduce the identity of x sub 2. Where in the second row, it's x sub 2 plus 3x sub 3, which is equal to negative 1. We know x sub 3 is equal to negative 1. Therefore, the equation becomes x sub 2 minus 3 equals to 1. And as a result, x sub 2 is simply 2. Now, we only need to solve for x of 1. How are we going to do that? The same way we're going to do that the same way we looked for x of 2. So we have x of 1 minus 3x of 2, and then there's a 0, and 0 times anything is 0, which is equal to negative 5. We know x of 1 is negative 1, and we know x of 2 is 2, which is equal to negative 5. Correction. There is no x of 1. We're solving for x of 1. My bad. As a result, x of 1 is equal to 1. And there you have it. Based on observation and direct substitution, we have our x variables, where x is equal to 1 to negative 1. And does this mean we're finished? Yes. Yes, it does. So yeah, we're now able to solve a linear system using LU-Factorization, as well as finding the LU-Factorization itself. Congratulations, guys. If you have any criticism or any further concerns, inquiries, just drop them below in the comments and I'll clear that up immediately. Thank you, guys.